it defines a series of numbers.
Oh, it's a define, so it's a definition. Good. A relationship between numbers? Well, that's a start. I kind of dig that. How does it do that? Like, how is there any special things that are like against the law? Like, for instance, you're not allowed to marry your first cousin. That's not key. Is there anything like with these kind of functions, these relationships that are not key, so to speak? How about you, Garth?
Not really. Almost any series of numbers can be related.
This is true, but that doesn't mean they're functions. For instance, Mr. Groom. If a person tried to have like 3 or 4 girlfriends at the same time, how well does that fly? It doesn't. You see, your home life, if you will, is not functioning. You see that? Because you're only allowed typically what? One. And even then, no guarantee it's going to work. Okay, all right, but one at a time. And so as you recall, perhaps, that each x has how many y's? Yes, has how many? 1. And the big kids say, and only 1 y. Right? That's how you know it's a function. You tell me a number for x, I will match it up with 1 y value. Right? Now, from a graph, what does that look like? If you look at a graph, how do you know it's a function?
Doesn't it pass the vertical line test?
It passes the vertical line test. And if it passes it, for instance, wow, anytime I drop a vertical line, this is the line, let's say x equals 3. How many times is it?
Can I get a piece of paper from the printer?
Help yourself. Knock yourself out. When you get to x equals 3 right here, how many y's match up with x equals 3 when x is 3? 1. Is there any place where there's more than 1 in this case? Like here or here or here? Nope. And so because it only touches one time, that graph is a function. That's what we say. Yay. Now, how is that from a calculator standpoint? How is that a big deal? How is that kind of an important deal? Well, I think it's kind of a big deal because what if you did the tangent 12 on your calculator? Now, I don't know. Well, if you do this on your calculator, if there was more than one y, how if you know you got the right one? How would you know? You wouldn't. When you say the square root of 9, what do you expect to get? 3. You expect 3. What if it said it could be 3 or 12 or negative 7 or 18 or 5? Yeah. What? No. When I push the button, I want one answer. All right? It's like this, too, in some respects. I have one rule, and that's just don't piss me off. I don't even mention it in this class, to be honest with you. But my other classes I do. Just don't piss me off. But what does that mean? I don't know. You're going to make a mess everywhere. That's going to piss me off. All right? And it's easier because I can be consistent with that, right? If you're like one of these people like, I won't mention names, but there's a certain person in this building who always says, I don't have favorites. Yeah, because they do. And when one person does it, oh, that's totally fine. Another person, they get, oh, holy heck fire if our rains down on them every time they do it. And you're like, okay, listen, if one person does it and it's a big deal, then it should be a big deal for everybody, okay? It's that idea of fairness, if you will, right? So functions, kind of a big deal, okay, in calculus. If we don't have a function, we are kind of screwed. For instance, if you run into this guy, and I say, hey, look at x equals 2 right here, what is the slope of this function right here? And you're like, I don't know, do you mean that one or do you mean this one? Exactly. What do you mean exactly? Well, what is the slope? And you're like, which one, Mr. Grew? It's kind of a big deal. Without that, we can't do this, okay? So we're going to have to be clear about our functions. We're going to have to be clear about, is this functional? Is it not functional? If it is, are we good to go, yay or nay? It's kind of a big deal. Hopefully, it comes back to you sooner rather than later. Also, what about domain? The definition of a domain. Oh, I should have checked attendance. Oh, wait, I do have this deal here. Let's look at this and make people feel uncomfortable. Oops, wait, no, that's the right one to start with. Where did she go? Brooklyn. Where's Brooklyn? Brooklyn. I'm looking at her, right? Good for you. You didn't look up.
Sorry, I was writing stuff.
By the way, that's a classic move right there. Don't know who you're talking about. What is the definition of domain?
Well, domain and range, so it's the X and Y values.
So which one's which?
Domain and Y, right? No. Opposite. X. X values.
These are the allowable X values, yes? What do I mean by allowable, Hallie? Allowable.
Isn't it kind of like the limit of X, like how far X can go? Sometimes it can go, like it's all the numbers, like all real X numbers.
But why might it not be all reals? That's good, you're right. It could be all reals. Might not be. Like at Taco Bell, can you order any real number of tacos over there?
Sure.
Cool, I'd like to have pi tacos. Square root of 2. Negative square root of 2. Yeah! Yeah, no. Be weird. Well, I think over there it'd be like, whole numbers, right? 0, 1, 2, 3, 4, 5. Mm-hmm. Sure. So what are some things we can't do? Well, we can't square root negatives, right? Right. So in this situation, x has to be bigger than or equal to 0. What else? What?
1 over x.
Oh, yeah. Thou shalt not divide by 0. Right? What else? Those are kind of the two big, of the 10 commandments for math. Those are kind of like probably 1 and 2. Boom, boom, back and forth right there. Yeah. If you had e to the x power, what can you put up there? Anything? Everything? Is there anything you can't put up there? E to the 0 is 1. I'm pretty down with that. E to the negative 1 is just 1 over e. It feels like that's probably okay. E to the square root of 2 seems like a weird thing to do, but it's totally doable. So they're all reals here, yeah? Right? And so, if you think about it, every function that we've looked at, for instance, we've looked at this guy until we're about blue in the face, right? All reals, okay. That linear, obviously. What is this function called? Do you remember? Y equals c. Like y equals 2. We just call this a constant function, yeah? And in this year, we'll talk about that a lot. Like if you're driving at a constant speed, like 50 miles an hour, how fast is your speed changing? And you're like, it's not, Mr. Groom. Cool! Because when we do derivatives, the derivative is just a rate of change. So how fast is it changing? It's not, so it's 0. Nice. So we'll deal with him quite a bit. It's one of my favorite functions. Yeah, this guy here, what about him? Oh, for God's sakes, they're playing me on a speaker. I gotta close the door. That's gonna drive me to drink. They're sitting on the table. Yeah. Anyway, whatever. Anyway, so there it is. And this is quadratic, yes? Yes? Nice. What if it was like this, Zach? What if it was just, like a x to the n plus b x to the n minus 1 plus c x to the n minus 2 and so forth and so on and so forth. What do we call that guy? Okay. Ooh, tricky dicky. So you're thinking back in pre-K in physics when we did some regressions, and then you're not wrong, but it's a polynomial, right? This is a polynomial. And if you recall, a polynomial is the generic family from whence the quadratic, the linear, the constant all derive, yes? They are all versions of that guy, right? What must be true, though? N must be a what? A whole number. A positive whole number. Okay? So x cubed, and then x squared, and then x, and then a constant, yes? Eventually you run out. You get down to x to the 0 power. Okay? So any of these guys, these are all reals. That's their domains. There's nothing that I can't do that to. There's no number that I can't cube. There's no real number that I can't cube. Okay? They're all doable. And then, What else? We had some trig functions, right? Sine of x and cosine of x. Remember what these functions look like? Let's pick on somebody I haven't picked on yet. Oh, for God's sakes. Oh, for crying out loud. Why can't I think of your name? It's Lacey. It is Lacey. I've got 2 Lacey's this year. I've never had a Lacey before in class. I've got 2 of them now. Good for me. Lacey, what does a sine function look like? A wave. Does it start at the origin, or does it start high or low, or do you know?
I think it starts high, low, at the origin.
Starts at the origin. Does it go up first or down first?
Oh.
Yes, it does. Nice. Hey, that's sine of x. Right? How high does it go, max and min? Yeah. And -1. Yeah. And how long does it take to repeat itself as a general rule before I do anything to it?
1, 2.
There you go. Good girl. 2 pi. Right? Or if you prefer, 360 degrees, right? Until I mess with it, I can monkey with it, make it go faster or slower, make it go higher, lower, whatever, yeah? What does cosine look like? Very similar, except what? Starts high. There you go. Whee! Still goes to 1 and -1. Still takes 2 pi to get the job done. Right? And it just keeps repeating, Hannah, yes? Forever. Right? So think about this. What is the domain of this guy? These guys both have all reals for domain, right? Oops, all reals. Right? What would the range be on this feller? On this sine function? I think normal people would write it this way, but -1 to 1. But you do what you want to do. I know what you're talking about. By the way, there will be a few times this year when you'll see me write some things in a different way, not to piss you off. You might think so, but I didn't do it on purpose to piss you off. To show you there's other ways of doing it. Okay? Another way to write this is to write it like so. So absolute value is distance from 0, yes? So the most that you'll ever be from 0 is 1 unit. That could be on either side. Okay? So a lot of books will write the answer like this. You'll write it one way. You'll see it the other way. You're like, I'm wrong. No, you're not. You're fine. Okay. Another way to write it, of course, is to do it in interval notation. You've seen this before as well, I'm sure. Yes? And so any of those, and from one problem to the next, your book might write it one way. You write it the other way. You're like, what? You need to be confident. Because when you go from this class to another math class down the line, perhaps, and you see it one way versus the other way, you need to be fluent in that. Whereas other people, certain teachers only teach it one way as if it was the gospel. And other people like myself realize that, hey, you need to be comfortable either way. All right? It's really a Chevy Ford deal. You get in, you probably should be able to find out where the dadgum key is, okay, and the brake pedal and stuff, all right? It shouldn't be this, where's the brakes? Okay, if you're asking yourself where the brake is, you've got problems, all right? Yeah, the radio's in a different place. We can probably figure that out. But like starting it, stopping it, that sort of thing, you should be fluent in either direction, okay? It's pretty straightforward things. All right, what other kind of functions? Sine, cosines, polynomials. What else have we learned? Lots more. Come on, give me another one. Pre-cal people. What? Log functions. And their kissing cousins, the exponentials. Let's start with exponentials. So this would be something like y equals b to the x, right? Nice. Could be e to the x. Could be 3 to the x. Could be 10 to the x. Don't really care. Not a big deal. Look at the domain of this guy. The domain is all reals. Right? But what's the range of this fellow? What are the y's here? Oh, for God's sake, don't answer yet. It's oh, Judas Priest. It's J. No, it's not Jacob. Oh, come on. It's oh, for God's sakes. Haynes, for God's sakes, there you are. Yeah, I was just looking for your name. Yeah. Okay, so what do you know about the range of this fella? Greater than 0. Love it. Absolutely love it. Greater than 0. Strictly greater than 0. Right? Whereas this is, x goes from here to here. I'm going to write it this way just for fun this time. Okay? By the way, I showed this to your friend's school a few years ago when I wrote it because I thought it was being very clever when I wrote this. And she's like, okay. And I'm like, greater than or equal to 0. And I'm like, no, you're reading it wrong. That says non-negative. All right? There are days when it's hard to be non-negative. All right? I'm not positive, just non-negative. All right? And very hard some days. Okay? But in this problem here, we're saying greater than 0. Now, what's the inverse of this function? Okay? Well, the inverse of this function is a logarithm. So y equals, the log base b of x. Now, when I did the inverse, these are inverses of each other, what happens to my x's? My x's become my y's, and my y's become my x's, yes? So what's going to happen down here? My domain is going to become x is greater than 0, and my range is going to become negative infinity to infinity. And so that is why, friends, the log function looks like that. Okay? Now, I don't know how Patterson does it anymore. He used to, I know, do it this way, but whatever. I'm going to show it to you my way. Here's the line, if you remember, y equals x, yes?
Yes.
And how are inverses related to each other? They're reflections over that line, yes? So what was in quadrant 2 ends up in quadrant 4, yes? And what was in quadrant 1, well, stays in quadrant 1, doesn't it? It just ends up on the other side of this business, right? And so that is why when you reflect this business over here, it ends up down here. That's a reflection straight from here to here. And these guys get reflected, you know, down into here like so. That is why the log function looks like it does. Okay? And we will be using logs a lot. I like logarithms. If you don't like logarithms, you've not been doing it right, Angel, because they're really freaking cool. Okay? Now, when I learned them, by the way, I will say this. When I learned logarithms, they were ridiculously boring, painfully gross, and with no real connection that I could see as a student to where they would be used. Okay, but calculus is a place where they show up a lot, and we will be using them a great deal. So get comfy with them because they're fun. Don't hate, right? They're really fun. All right, now, so let's see. A few things we're going to be doing a lot this year with is, dealing with some stuff like this. You won't deal with this as much quite this way, but you will have to do it some. So let's just review real quick. 8 negative 3. Okay. Y equals mx plus b. Let's do this here. What would my equation be? How do I do it? What's my slope? How do I find slope? Yes.
Rise over run.
Rise over run, by God. All right, so slope is equal to rise over run. That's cool. All right, so what is the rise? Connor?
y2 minus y1.
All right, so y2 minus y1. I had the hardest time with that when I was a kid. Which one's y1? The teacher would always say this to me, it doesn't matter, pick one, Jay. Cool, so I did. And then I'd say, well, that must be true for x1 too. Wrong! So I'd pick this one for x1 and I'd pick this one for y1 and I'd be like, oh, you moron. All right, so you got to be consistent. But so which one do you want? So you want to do 7 minus a minus 3?
Yeah.
I dig that. So then it would be 3 minus 8. So 10 over negative 5. So negative 2. Right? And then a y equals negative 2x plus b. It's so distracting to hear myself talking in the background.
You put 7 minus.
Oh, brah! Thank you. Woo! Woo! Doggy. There we go. Sorry about that. So y equals negative 2x plus 13 or some such. Yes? Nice. Nice. Ta-da! And of course, if you graph it, it really ought to look right. Yes? Right? Now, I use Desmos a lot. If you've not used Desmos, you're missing the boat. I don't know where you've been. I don't know who you are or what your dealio is. But you really should get comfy with it. Hey, play good tonight. Where are you playing at?
Astoria.
Oh, yeah, I heard that. Good for you. Have fun. So what was it? 3 negative 7, is that right? 3 7?
3 7.
Yep. And the other one was?
8 negative 3. Yeah.
Voila! And my equation is negative 2x, yes? Negative 2x plus 13. And if I put it on projector mode, I bet you can actually see it. Shut up. Look at that. How cool is that? Yay, I'm right. Yay, me. Good for us. Okay? All right? Again, we'll be doing it. Hopefully that's review. I'm not going to spend a lot of time on that. If you can't do linear functions, you got to figure it out pretty quick because it's something you're supposed to know. How about this guy here? How do you solve this equation? We got about time for one more problem. This is a good one to finish on today, I think. Yeah, equals 11. Sure, that's gross. How do you solve this one by hand?
Make one of
Elimination. I love it. So what are you going to do? No, you're totally right. I hate substitution. I used to love it, but when I was a kid, they didn't teach us anything but substitution. How fun is that going to be? Solve for y. You're going to have fractions in everything. And then I get to hear about, well, I hate fractions. That's why elimination's the bomb. So, for instance, let's get their x's to be the same. Now, me personally, I like to get them the same and then subtract. That just is the way I do it. If you were taught to get them opposites and add, that's weird, but go ahead. I can play either game. Okay? That's going to give me 12x plus 8y equal 40. And 12x plus 15y equal 33. All right, now my x's are the same. By the way, could have multiplied by 5 and 2, got my y's the same. Same difference. That's whatever floats your boat, okay? If 3 went into 4, then it would be really easy just to multiply one of the equations. That's nicer, but it doesn't matter. Hey, let's subtract. 12x minus 12x is 0. Nice. 8 minus 15 is negative 7y. Well, look what I did here. 40 minus 33 is 7. It's like I planned it. I didn't. That's weird. And so y, of course, is negative 1. Nice. How do I find x? Plug it in. Which one? All 4 of them? There's one of them. Yeah, it doesn't matter. Whichever one makes you happy. So 3x minus 2 equals 10. Right? Right. Yeah, x is faux. Faux negative 1. Now what's supposed to happen at faux negative 1? They cross. That's right. So let's just see that real quick just to make this round us out this day. What was the, read them to me. Is it 3x?
3x plus 2y.
Oops. Crap. 2y. Nope. Equals 10. And 4x.
Plus 5y is 11.
Oh, you are. Plus 5 equals 11. Oh! Ta-da! Now, we will be doing a lot more with algebra maybe than you've done in the past to feel comfortable with. You've got to be better at your algebra, okay, for calculus. The hardest part of this class is the algebra. That's a fact. Take it to the bank, all right? But it's calculus. Just like the hardest part of physics a lot of times is the math. Yeah. So you've got to be on top of that, all right? So you're going to learn some stuff you'll be like, I don't remember how to do that. Well, I'm going to learn you how to do it again. Okay, it's going to be okay when it's all said and done, but you got to be with me on this, okay? Now, let's go up to the library, get our books. I'll be right